Arresting the failure of fluid coupling mechanism during electrical starting in battle tanks. A project presented by Namit V, Rohit Kuti and Shyam M of Mechanical Department, Vailtech Multitech, Dr. Rangarajan, Dr. Shakuntala Engineering College. The T90 main battle tank is powered by the V84MS 4-stroke 12-cylinder multi-fuel diesel engine delivering 840 horsepower. The fluid coupling mechanism is an integral part of the starter generator drive in electrical starting. It consists of components like distribution cork, housing, boosters, retracting spring, drive shaft, drive coupling, etc. The subject item is of major assembly in the IGB. The IGB transmits the engine torque to two side gearboxes and also drives other units like the air compressor, fan drive of cooling fan and operating the suction pump for bringing out the oil after lubrication. Indigenization of T72 and T90 tanks by Heavy Vehicles Factory Avadi at the soft duration and low cost is the need of production. This will improve the reduction in spending towards defense and saving foreign exchequer. The initiative made by us as to forward the modification to reduce frequent failure of tanks during electrical starting. Now for the problem. During electrical starting, excess oil is pumped into the fluid coupling for the first 5 seconds. Due to the increase of pressure in the turbine impeller setup of the fluid coupling, oil leak takes place through the riveted sections. Due to the oil leaks, the pressure drops, which in turn causes the failure of fluid coupling during electrical starting of the battle tanks. Now our aim of the project is to reduce the leakage of the oil from the fluid coupling setup, to select the most economical leak preventive measure to enhance the lifespan of the above mentioned setup. Now this is the position of the IGB in the tank, and there are further pictures which cannot be displayed on the internet. So we are actually skipping the main images of the fluid coupling and the intermediate gearbox. Now for the proposed methods. We have actually proposed several methods to curb the leakage of oil through the fluid coupling. Those are usage of threaded screws in the place of rivets, usage of metal fasteners, counterboring the rivets, pan head, flat head and half countersunk rivets, and the other method is to internal threading in the turbine impeller setup and usage of gaskets to reduce the leakage. The test procedure consists of two sections. The first is to test the compressor. The entire IGB assembly is fixed. The engine mount is connected with the motor. The motor is run at 1600 RPM. The IGB is run for 15 minutes at neutral condition. The gear lever is turned to low position for 15 minutes and run at 2000 RPM. Lever is shifted to high position and run for 15 minutes at 3200 RPM. The compressor is tested for a pressure of 150 kg per centimeter square in 26.5 minutes. Now for the testing method for the starter mode. Prior to starting, the generator drive of the two D20 switches are checked separately. Here each switch is activated for 5 switching with a gap of 4 to 5 seconds in between. Now both the switches are activated together for starting the starter generator drive mechanism. For each switching, 5 to 20 seconds of time is provided after each actuation. Then 15 to 20 minutes time is given after 5 actuation for cooling electrical equipment of the stand. Absence of leakage on oil joints, oil seals are checked. Absence of local heatings are checked. Absence of noise, jerks and kicks are checked. So this is the basic testing procedure that we have followed. When we used threaded screws, there were crack propagation and it was actually pretty expensive, more expensive than the rivets. The crack propagation was due to the fact that the wall of the casing, the fluid coupling casing, is actually very thin. And the next method is to use metal fasteners. When we use metal fasteners, we will have obstructive metal parts which will actually obstruct the rotational movement. So metal fasteners have to be ruled out. Now next is counterboring. Counterboring also faces similar kind of setback which we faced in threaded screws. Since the thickness of the wall is reduced, the crack propagation is sure to occur. In using pan head, flat head and half countersunk rivets, again the obstruction of rotational movement is seen. Now when we used countersinking rivets, there was observed that it had minimal seepage of oil after repeated testing. Then we tried the other proposed methods for the turbine impeller setup, that is internal threading in the turbine impeller setup. The internal threading prevented excessive leakage of oil. In fact, there was no leakage at all. And gaskets would require frequent replacement, and use of threading eliminated the need of gaskets. This is the exploded view of the fluid coupling. We can see each and every distinctive parts of the fluid coupling, and the part 112 is the actually actually the simple rivets that is used currently. The project scope. We are following part process from the beginning to the end stage. Thus, by going through the process, we are able to identify the different problems arising at different stages of the operation. The following slide is a representation of the scope of our project. See, we have reduced leakage, increased lifespan of the fluid coupling, reduced maintenance cost, eliminates air cranking method. This is another method for starting the tanks when the electrical starting fails. So since the fluid coupling is fixed, the need for air cranking method is eliminated and more economically feasible. Conclusion. The causes for frequent failure of fluid coupling in battle tanks have been identified by collecting and analyzing the relevant data. The problems were identified in the design of the turbine impeller setup and the rivets. Possible solution for rectification and reduction of the defect were formulated after theoretical deliberation and experimental testing in controlled environments. Suitable solutions are using of countersunk rivets and threading the turbine impeller setup. These solutions were finally recommended to the Heavy Vehicles Factory and Combat Vehicles Research and Development